Maxine, and this is my presentation for Lab 4, which was on bar magnets. So in this lab, the goal was just to measure the strength of bar magnets and how the strength of those bar magnets changes relative to the position and distance. So we determined the magnetic dipole moment for the bar magnets. I don't know why it says magnetic. Oops, oh well. And we used that to determine the magnetic field. And so overall, we found that the bar magnets have dipole magnetic fields going from south to north poles. And that law is kind of the physics principle at play here. So the magnetic field is equal to K magnetic times 2 mu over R cubed. And the mu is the A times I. A field times I. A vector times I. Anyway, oops. So this is kind of the experimental setup. Several different distances, as is pictured here. One also more parallel, one more perpendicular. And we measured and plotted these data points. Speaking of plotting the data points, here's the data. This was what we found for all the data here. Yeah, I'll just kind of keep that here. We've ended up finding a plotting of negative 2.975x minus 20.46 equals y. I don't know why I said that backwards. Anyway, that is the data here. And yeah. And then here's my glow script code. I'll zoom in on each little part here. Yep, I do think, I'll bring this up later. I think I got my mu mag like a decimal point or so off, so that might have impacted my results. Anyway, I just noticed that. Anyway, moving on. Yeah. Cool. So this was the results I got. Again, it's like the directions and stuff should be right, but it might be a little bit wrong in terms of magnitude, but this is what I got for all of my stuff. Yay. Awesome. So possible points of error, as I said earlier, the miscalculation potentially of the mu mag, and also nearby metal or nearby electronics could have messed with the magnetic field. I think our phones were probably on the table, our computers were definitely on the table, and at least one or two of our computers were pretty close to the experiment. And then also just, inconsistency with measurement, and just like human error. We were having a situation where the numbers on the thing were fluctuating a lot, and so we kind of just averaged it out, or tried to, but we obviously could have very well been wrong there. Anyway, what if you hadn't oriented your experiment to compensate for the magnetic north and instead oriented it to an intermediate angle? Well, it would have been wrong. The x component of the magnetic field would have changed. The data would have gotten skewed and caused an incorrect slope and incorrect constant k to be calculated. So just the results would have been wrong overall. And in terms of what does it mean, what if we stuck two identical magnets end to end? So the magnetic field would double at each point and the direction wouldn't change, and due to superposition, they would all just add together. Okay, that is my presentation. Thank you.